and every components or devices or hardware, they are interconnecting to each other for communication purpose, and how they communicate, what are the different types of protocols they're going to use, what are the different types of softwares we supposed to use for IoT. So this is what today's session. In today's session, we discuss these things, and you should know what is the role of the software, especially the type of the softwares we are going to use, and type of the softwares we are using in device side, IoT devices, and type of the softwares we are going to use IoT servers, because servers plays very important role with respect to the devices which are connected. Devices simple physical components, but to transmit or receive the data, we need the support of the servers, and also we need the particular softwares which can support each devices to operate itself. So those concepts we are going to discuss. Hope my screen is visible. I will be changing to the, still people are joining. I'll let them join. There are a lot of people are there. I need to admit. Okay. There are some issues with the previous class. Some students, they were telling, sir, we are not able to join the sessions and all. Hope those students can join today. Some of them, and as we all know that only eligible students can join. Yesterday's strength was really good. Today also I expect good strength. Okay, Deepshi is attending today. I'll fine. The 1 minute, let me wait so that I can start exactly by 12 o'clock. So just recall what we have discussed in the previous session. Okay, previous multiple classes, like different IoT architectures, conceptual frameworks from different organizations or different services. Then we move on to the step-by-step explanation of each one. Yeah, now it is 12 o'clock. Let me just, yeah, still people are joining, rejoining it. Because of network issue, we are having all these things. Let me just change my option so that nobody will disturb me in session. Yeah. Okay, cool. Now we'll move ahead. So last class, I have discussed about microcontroller. What are the different types of microcontrollers will be there generally in your IoT architecture. So just to revise that, basically we will be having Atmega series, or we will be having ARM series. Either we will be having most of the popular type of the microcontrollers are Atmega and also ARM. So a lot of scopes are there with respect to this. If you really want to go with the core companies, Atmega, lot of electronics engineers requirements are there. Even ARM also, each and every year they are coming up with the new versions of the processors as controllers. So they are having a lot of challenges. They need to give the services for varieties of data. So lot of requirements are there. If you are really good in hardware, really good in microcontroller, really good in machine, that is assembly level language, you have a very good positions in these two companies itself. So you can brush up your microcontroller knowledge and you can apply for that one. Just 1 or 2 interviews if you attend, you are through into these companies itself. And you will be serving in the hardware, core hardware industries. With that one, additional softwares also you can keep on learning. You can update yourself. Fine. So just to move in the previous class, I told you Atmega 328, Atmega 32, Mu4, ARM Cortex and ARM LPC. These are all the processors or controllers which will be used in your IoT. Generally, microcontroller units comprise of a processor, memory, and several other hardware units which are interfaced together. We need to interface because microcontroller is a blend of all these things. Blend of a processor, blend of the memory device, clock, and also you will be having different peripherals which are interrelated. They are put together, they will be called as a microcontroller. A simple block diagram is shown yesterday. We will be having a processor, internal RAM, internal flash, timers. That's what I'm telling. Clock, timer, both are different. Serial IO port, parallel IO ports, general purpose IO ports, all are put together called as a your microcontrollers. Moving ahead, today's class, communication module. Different types of communications need to be established between the IoT devices which are connected. Sometimes we need to get the data from the other end. Sometimes we need to put the data from our end to the other end, or from the IoT device to IoT server. Sometimes from the IoT server we need to get the data. So get operation, put operation will be there. Similarly, we will be having delete, post. Okay, so these are all the some of the operation where HTTP protocol will be taking care. And I told you in the yesterday's class also, handshaking is very much essential for communicating between the two different ends or two different devices. Very important. Request, response, acknowledgement. These three steps are very much required. So moving ahead with respect to software, generally we will be having softwares are two components. So generally, IoT software consists of two components. One is software at the IoT device, that is the end device, and software at the your server, that is IoT server. So it is in a simple block diagram. It's been given like this. See the block diagram. Bottom two blocks, what we are having, they comprises the end devices, and the top what we are going to have. This the top one is with respect to the server. IoT server, the software with respect to the IoT server. At the bottom, the software with respect to IoT devices itself. Generally, the devices, as we all know that one, will be having the sensors, will be having machines, will be having the different edge nodes. Edge nodes. Edge nodes are called the end nodes. We call that one. We will be having sensors, or where they are going to sense the different types of data. We will be having the machines. They're going to perform some operations based on the user's input. Machines are keep on working and they generate some input, and those inputs will be given to the IoT infrastructure. Similarly, intelligent edge nodes of different types, they will be working with respect to time or working with respect to the predefined data. They are called as intelligent nodes. Intelligent nodes in the sense, just simple example is your water moisture sensor. It's a simple intelligent node. A fire sensor, it's a simple intelligent node. Okay, a thermal sensor, that is also, it keeps checking the heat generated. Based on that one, automatically it's going to work. Similarly, a simple example, in your washing machine itself, water is pumping into the washing machine, and what if the water is pumped up to the maximum level, the sensor automatically says that one, water pumping is sufficient, need to stop the water pumping. So that is an intelligent node, we can call that one. Similarly, in IoT devices also, Internet of Things also, lot of devices, they work intelligently based on the data. They customize themselves what to do. They are called as intelligent devices. So IoT devices hardware, they're at the bottom, and your servers will be at the top. So we will be having softwares in between. See, IoT device softwares for gathering the data, enriching the data, and communication purpose. What they will do, simply having device is not sufficient. The softwares will take care of how to gather the data, how to enrich them, how to filter them. Okay, what are the data need to be collected, what are the data need to be omitted. That is what enrichment will call that. Similarly, communication, where exactly they need to be communicated. All those things are the software which are available at the end devices. Similarly, software at the server, they will be taking care of data analysis, data abstraction, and data accumulation. These operations will be taken care by your server end. So this is two different types of softwares. One is the software at the device end, other is the software at the server end. What the device and software will do, they will just gather, enrich, and communicate. Any issues? If you have any issues, you can interact with me. If there is no issue, I'll just move ahead with the discussion. And server end, they will be performing the different operations like integration, collaboration, and process, application reporting, analysis, and controlling. Everything will be taken care by your software of the IoT server. Now, other than end device and also server, that is one is the IoT device at the bottom end and IoT server at the top. We will be having the middlewares. Open IoT is an open source middleware. Is an example. Open IoT is an example, which is the example for your middleware. It enables communication with sensor clouds as well as the cloud-based sensing as a service. The middleware, what it will do is mainly for communicating between the cloud and also the cloud-based sensing as a service. IoT sys is one more middleware. Open IoT is one middleware. IoT sys is another middleware, which enables provisioning of communication stack for smart devices using IPv6, OBIX, 6 LoWPAN, COAP, and multiple standards and protocol. So different types of middlewares, they are performing the different operations. Similarly, OBIX is a standard XML and web service protocol. OBIX in the sense Open Building Information Exchange. There is the expansion for that one. So two different middlewares have been given here. One middleware is communicating between the cloud and also that is cloud as well as the cloud-based sensing as a device. Second one is IoT system is a middleware which enables provisioning of the communication stack for smart devices. What are the different smart devices with the different protocols? And the operating systems what we are going to use. There are so many operating systems which are meant for your IoT. Example is RIoT, Raspbian. Raspbian is mainly for Raspberry Pi, Alljohns, Spark, and Contiki. RIoT is an operating system for IoT devices. RIoT. RIoT is the name. RIoT support both developer and multiple architectures, including ARM7, Cortex M0, Cortex M3, Cortex M4. So these are all the families of your ARM standard microprocessors and also MSPs, that is Texas Instruments. Texas Instrument, TI means Texas Instruments. So where your RIoT supports almost all the types of the IoT devices. It is supporting your ARM processors, controllers, it's supporting Cortex, it's supporting Texas Instruments, supporting the microprocessors, everything. Similarly, second type of the RTOS, that is your operating system, Raspbian, is a popular Raspberry Pi operating system that is based on the Debian distribution of Linux. So it is the version of the Linux mainly for your Raspberry Pi. And the third one, Alljohn, is an open source OS created by Qualcomm, where you people are well versed with the Qualcomm, one of the best industry, major industry, which is meant for your, uh, just 1 second, your real-time mobile communication. That is Qualcomm mainly deals with your mobile communication. It's a cross-platform OS with APIs available for Android. See, one of the major advantage of this Alljoy is for Android also, for iOS also. It's a cross-platform. OS X, Linux, and Windows. Every operating systems can be interrelated with respect to your Alljohn. It includes a framework and a set of services. It enables the manufacturers to create compatible devices. Obviously, what happens, because if Android is there, it may not support iOS. If iOS is there, it will not support Android. So we need a platform which is called as a cross platform where it can support all the manufacturers and all the services. It's a compatible purpose. It's going to be used for all jobs. Fourth one is the Spark. Is a distributed cloud-based IoT operating system and web-based IDE, integrated development environment. It is basically a distributed. It's basically a cloud-based IoT and operating system, and it's also a web-based. It is distributed, cloud-based, and also web-based IDE. It includes a command line interface, support for multiple languages and libraries for working with several different IoT services. Multiple languages, like you may be having different programming languages, this will support all of them. That is Spark. Contic is the first final one. OS is an open source multitasking operating system. It includes different types of the protocols like LoWPAN, RPL, UDP, DTLS, and TCP/IP. So UDP also it is supported. TCP/IP is supporting. UDP is generally is a connectionless. TCP is a connection oriented. So your Contiki OS it support both connectionless and also connection oriented protocols which are required in low power wireless IoT devices. Examples of applications are street light in smart cities, which requires just 30 KB ROM and 10 KB RAM. See, basically, the street lights, smart street lights, will call that one smart street light. Whenever the any person is moving in front of the street light, the light should be on. When he's just move away from that particular street light, the light should be off. So that is what smart street lighting. It can reduce the power consumption. Power consumption can be reduced itself can be reduced itself because only when the obstacle comes when the a vehicle or a person is moving in front of the street light, the light should be on. Otherwise, light can be switched off itself. So this is very good uh, societal benefit of project where almost most of the time either in malls or in any highways and all, most of the time the lights will be on itself. Instead of that one, whenever it is required we should on the light, whenever it is not required it should be automatically should switch off. So generally what happens currently, as I have seen, manually we are switching on the lights and switching off the lights. You usually evening 6:30 p.m. to morning 6:30 a.m. the lights will be on in almost all the places. It means there is public utility places. Instead of that one, whenever a vehicle comes, whenever a person comes, whenever any requirement is there, at that time the lights can be on, otherwise the light can be switched off. So it almost reduces the 80 to 90% of the power consumption. So where your contiguous OS will support that one. That is with respect to different operating system for the IoT, and we have discussed the middleware. We should also know the firmware. First of all, we should know what exactly firmware is, where it's going to be integration of both hardware and software. We call it as a firmware. ThinkSquare Mist is an open source firmware that is software embedded in the hardware. Software embedded in the hardware. But what is the limitation here is this particular software can operate only that particular hardware, only those functionalities. It cannot perform the general operations. It has to perform the micro oven, okay, only that much it's going to operate. My only washing machine, only that particular software, it will take care of the washing machines itself. So software embedded with the hardware inside the hardware is called as a firmware. For a true internet connectivity or to the IoT, it enables resilient wireless mesh networking. Several microcontrollers with a range of wireless radio supports things missed. So things missed or things square missed is one of the firmware which is mainly used as for particular application itself. This is with respect to softwares, middleware, and firmware. Next, we need to go for different types of development tools and open source framework for IoT implementation. We should know the different tools which are available for developments. So Eclipse, most of the time as a engineering students, any projects, any academic projects, even I am repeating this one, if you want to do, Eclipse supports for that one. Eclipse provides open source implementation of standards such as MQTT, that is message queue telemetry transmission, okay, and COAP, OMADM, and OMA low okay, LWM2M. We call that one LWM2M, and tools for working with different services and framework that enable an open Internet of Things. So Eclipse is the most popular open source tool. Eclipse developed the IoT programming language Lua. Eclipse website provides sandbox environment for experimenting with the tools and Lua demo. So when you go for Eclipse IoT.eclipse, when you click on this, it will go open. It will show you what are all the functionalities, what are the facilities which are available, what are the operations we can perform over them. Eclipse related popular projects are Paho, Koneki, and Mihini. So these are the, as per the textbook we are discussing here. Now currently we have a lot of projects based on the Eclipse. Arduino development tools provides set of software that includes an IDE and the Arduino programming language. See, one is Eclipse, second one is Arduino IDE. So where the second one is using Arduino boards, we can able to develop the IoT based projects. So Arduino programming language for a hardware specification for interactive electronics that can sense and control more of the physical world. And the third one is Kinoma software platform. That is one more tool. And these three are basically used for development tools, development environments. Okay. And when we move on to APIs and device interfacing components, connectivity interface consists of communication APIs, device interfaces, and processing units. So when you look into the APIs, let us see what are the APIs will come into. Basically, we will be having a REST API and device interface. What are the different APIs will be having? So generally in REST API, when you look into REST API, connectivity interface consists of the communication APIs, device interfaces, and processing units. So there are so many processing units will be there, device APIs interfaces will be there, and communication APIs will be there. So when you want to communicate, okay, so publish or subscribe, REST, LWMTM, machine to machine, DTLS, TLS, okay, and different types of protocols will be there. COAP, COAP MQ, COAP SMS, and HTTP, MQTT. All these interfaces comes into picture. So these are all different types of protocols which are mainly used for your APIs. Okay, so embed API and device interfacing components. These things. These are all some of the basics we should know. Basically, the questions will be raised. What are the different APIs which are supporting the IoT? What are the different IDEs which are supporting the? Briefly explain the different types of the IDEs which can support the IoT. What are the different softwares which are used in IoT platform? What are the different types of software which are used for the server side? What are the different types of software which are used for the device side? So we should know each and everything. Though it gives theoretical knowledge, practically when you work on that one, you will come to know. So one of the thing is Eclipse. We can go for it. So I don't want to spend much time only discussing on Eclipse. We'll move ahead with the different next topic, that is platform and integration tools. What are the different platforms you are going to use? What are the different integration tools we'll be using? Things speak. If you discuss with your counterparts, that is with computer science students, they will be discussing with all these things. They will be knowing all these topics. What is ThinkSpeak? Similarly, Nimbits also. ThinkSpeak is an open data platform with an open API. It's an open data platform. It's open API, application program interface. Okay. It consists of APIs that enables real-time data collection, geolocation data, data processing, and visualization. See here, geolocation data. We are able to get the data of the different locations. Simple example is your navigation system, where location can be easily accessed. Your GPS, where each live locations, current locations and live locations you are getting. So it may use one of the tool called ThinkSpeak. It enables device status, messages and plugins. It can process HTTP request and store the process data. So your ThinkSpeak, a request will be sent and it's going to store the data. It can integrate multiple hardware and software platforms. Definitely. It supports Arduino, Raspberry Pi, IO Breeds, real-time IO, and electric IMP. So almost all the IoT devices will be supported by your ThinkSpeak. An important feature of ThinkSpeak is the support for MATLAB data analytics. So as you people, electronics people know about the MATLAB, ThinkSpeak will support MATLAB data analytics also. Mobile data analytics can be done, web application and social networks. What are the social networks we are having currently? Facebook, Twitter, Instagram, all those things. Everything will be supported by your ThinkSpeak. That is one type of the integration and platform. Second one is Nimbits is a cloud platform which supports multiple programming languages like Arduino, JavaScript, HTML, and R Nimbit Java library. The software deploys on Google App Engine, any J2E server on Amazon, EC2 or Raspberry Pi. It processes specific type of data and can also store the data. See, it processes a specific type of data and can also store the data. Data can be time or geostamp. Here also geostamp. And the third one is IoT toolkit. Fourth one is site where these are the different types of tools, platforms which can be used for your IoT. Toolkit offers smart object, API, HTTP to COAP, semantic mapping, and a variety of tools for integrating multiple IoT related sensor, network, and protocols. Siteware provision is a complete platform for managing IoT devices. It enables gathering of information, data, and integrating it with the external systems. Siteware can be used on Amazon's cloud or download it. So it can be used in Amazon cloud. Basically, Amazon will be using. It can be downloaded. It also integrates MongoDB, Apache HBase, and multiple big data tools. See, if you learn these things, some basics of this, you can do wonders with respect to your projects, development of your projects. See, I insist everyone to do your projects maximum by your own. Learn the tools, everything is available online. Learn them, spend some fun time, 10 to 15 minutes or 1 to 2 hours on those tools. Learn basics where you can deploy them, you can download them, and you can work on those particular tools to develop your projects. A small project by your end on your own will enhance your confidence. Confidence level will boost up, and where you can stand in front of anybody and you can explain it easily over there. So kindly see to that one. Any problem statement if you are getting, do on your own using all this type of tools. Other platforms are Microsoft Azure, TCS Connected Universe Platform, Zivili, Smart Living, the Things, and Exosite. So if you want, it's better to remember everything. Otherwise, some popular names like Microsoft Azure is there, MongoDB, TCS Connected Universe Platform, all are most popular as we know them. So if you know them, then it can easily explain about what are the different platforms which are available for the IoT development. Sources of IoT is the next topic. Examples of hardware sources for IoT prototype development are Arduino Uno and Microduino, BeagleBoard, and Raspberry. Uh, Texas Instruments is one of the organization. They are working on a lot of Arduino boards, lot of IoT based applications where they need support, and they're giving real time applications for students also. They're giving training also. So if you know those training, if you learn those things, you can develop your own projects. So your Arduino Microduino, BeagleBoard are some of the sources of IoT. Popular IoT development boards, that's what. These are all the popular IoT development boards: Arduino Uno, Microduino, Intel Galileo, and Intel Edition, BeagleBoard, so many. So that is, we'll go one by one. Arduino Uno is the first one. Arduino Uno board uses microcontroller at Mega. Arduino and includes Wi-Fi, Ethernet, USB port, micro SD card slot, and three reset buttons. So just 1 second, I'll just show you how exactly it looks. Arduino Uno board. It will be easy for you. See, only theory is not sufficient. Let us just copy this and place. See here, Arduino boards. You might have seen this when you are working on that one. Let me go for. You can also check what is the cost for them. See, a simple Arduino Uno board. This Arduino Uno board, it costs around 385 rupees. Just 385. Any my small projects you can see Arduino Uno R3 development board. So it's 550 rupees. Even it is costlier, 4800 is there. The costlier board, Arduino Uno. See, this Arduino Uno, where eBay India is providing, where you can mount different types of ICs and you can go ahead with that. See, you should know little bit of them then only it will be easy for you to check it. See, this is Arduino Rev 2 IoT board with Wi-Fi, Ethernet, SD card, Linux support, SSD. That is the same thing. See, Arduino Uno board, microcontroller Atmega that supports Arduino and include Wi-Fi, Ethernet, USB port, micro SD card slot, and 3 reset button. See the same thing here. It's having. Okay, so it will be having IoT with Wi-Fi, Ethernet, SD card, Linux support, SSH, Python. It supports Python program. Backside it looks like this. Okay, this is one thing. Microarduino, if you want to go for micro, it's a small board compatible with Arduino that can be stacked with the other boards. All the hardware design are open source. So now let us see how exactly it looks. uh, just 1 second. Microarduino board, see here, Microarduino board, different types are there. I'm just checking where exactly Microarduino board will be there. Yeah, it almost looks like, see here, Arduino Uno only it's showing, but showing is a Microarduino board. It's complete. See, it's almost similar to your Arduino, where it's going to work with. It's open source. All the hardware designs are open source. Similarly, Intel Galileo. Intel Galileo is a line of Arduino certified development board. It is line of audio certified development board. Galileo is based on the Intel x86 architecture. It is open source hardware that features the Intel X1000 Quark based SoC system on chip. Galileo is pin compatible with Arduino. It has 20 digital I/O pins, 12-bit PWM for more precise control, system on chip, analog inputs, and supports power over internet. Let us see that also, how it looks. See, Intel Galileo board. See here, Intel Galileo board is here. Little bit different. It is by Intel. So all the types are, it's a little bit costly. It's showing some around 6,175. It can work with, see the specification also given. Galileo is designed to support shield that operates either at 3.3 volts or 5 volts. The core operating voltage of Galileo is 3.3 volts. Galileo is a microcontroller board based on the Intel Quark SoC system on chip X1000. The same thing has been here. Intel SoC X1000 Quark based SoC. So this is one type of the board. So Arduino board we have seen, micro Arduino board we have seen, Intel Galileo also. Okay. So these are all the different types of boards which will support IoT application. Similarly, Intel Edition is also there. It's a compute model. Intel Edition is a compute model. It enables creation of prototypes and fast development of prototyping projects and rapidly produces IoT and variable computing devices. Rapidly produces IoT and variable computing devices. It enables seamless device internet networking and device to cloud communication. It includes foundation tools. The tools collect, store, and process data in the cloud and process rules on the data stream. It generates triggers and alerts based on the analysis, advanced analysis. Now let us see how exactly it looks. Intel Edison board. See here, Intel Edison board. It is a little bit bigger in size and their operation is a little bit more. It's going to be, so Intel Edition they are given here, Intel Edition they are given. So but we can check it out, the cost also we can check it. So it's mentioned Intel Edition, the chip they are mentioned, board user guide, how exactly we can work, what are the different types of projects, everything can be. So developer 13093 Spark Fun Electronics, something they are given, means from where we are going to get it. So this is intelligence as a compute model. So totally, it enables creation of prototypes and fast development of the prototyping projects and rapidly produce IoT variable. So the tools collect, stores, and process data in the cloud. Similarly, we'll be having the Beagle board. So lot of different types of boards. The final one we'll see how exactly Beagle board looks. See here, Beagle board. Beagle board is, it looks like this. 12,589 it's showing over there. A Raspberry Pi board, it's only 2,600. Beagle board, 3,000 something. It's mounted. Fan also has been mounted over here. Here, 4,000. Different types of Beagle boards are available. Beagle bone, 4,500. This is different. So different types of Beagle boards are there meant for here. See here, you can also see Beagle, Packet Beagle, Beagle board, Texas Instrument, Packet Beagle, ARM Cortex, everything you can able to see. All will support the IoT applications and IoT software. So let us move ahead. Beagle bone board has very low power requirement. It's a card like computer which can run Arduino and Linux. Both the hardware designs and the software design for IoT are open source. That is also one of the very important. Next one is Raspberry. As we have seen Arduino, similarly we will be having the Raspberry Pi wireless inverter kits, role of RFID and IoT application, wireless sensor networks, everything will be the features of your IoT. RASWIC, that is wireless inventors kit. RASWIC enables Raspberry Pi Wi-Fi and connected devices. It includes documentation for 29 different projects. See here, it includes documentation for 29 different projects, or you can come up with one of your own. Already 29 is there, and you can also develop one more or many more. There is a fee for the devices, but all of the included code is open source and can use it to build commercial products as well. So almost all the commercial products that are available in the market, we can easily develop using Raspberry Pi. Already 29 projects are available. Using them, we can develop our own, we can enhance them, we can develop different projects also, we can release to the market. Earlier, IoT systems were internet connected RFID based systems. I told you in the beginning, that is the inventor, okay, Kevin Austin. He was using the RFID. RFID enables tracking and inventory control, identification in supply chain systems, because every supply chain need to be controlled, verified, whether it is produced, released, or received by the customer. Everything has to be checked. So RFID will give all the data from the production to the service to the customer. Production from the beginning till the end until it reaches the customer. Everything will be taken care by your RFIDs. So supply chain and access to buildings and road tolls are secure toll center, store center entities. That's what. See, you cannot come out of the mall without removing the tags. Those tags are called RFID tags. Okay, so generally it may be a barcode tag will be there, or some of them are RFID tags. Without them, you cannot come out of the malls. It should be removed itself. Devices such as RFID based temperature sensors, RFID network have new applications in factory design, 3PL management, brand protection, and anti-counterfeiting in new business processes. For payment, leasing, insurance, and quality management, everywhere you are going to use the RFID. Similarly, when you go for wireless sensor networks, a huge wireless sensor network is huge. Without wireless sensor network, now nothing is there. Sensors can be networked using wireless technology and can now cooperatively monitor physical or environmental conditions. Sensors acquire data from remote locations which may not be easily accessible. See, we cannot directly physically go and access the data, but sensors can access the data because they are protected. We'll be using code and we'll be accessing the data. So in between, you cannot hack the data. It's very secure data. Each wireless sensor also has communication abilities for which uses the radio frequency transceivers. Each node either has an analog sensor with signal conditioner circuit or a digital sensor. Sensing can be done to monitor temperature, light intensity, presence of darkness, metal proximity, traffic, physical, chemical, and biological data. See, if you go to any shopping mall and all, they're going to use the what is that? Metal detectors. A metal detector is going to sense the metal. It's a sensor. It's going to sense, it's going to detect the metal. So Similarly, a temperature sensor, it's going to sense the temperature, it's going to digitally, it's going to display that one. So they are all not IoTs, but it can be connected to IoT. So a lot of sensors, wireless sensor networks are playing very important role in our daily life. WSN definition, what is WSN, what is WSN node, all those things. Okay, let me stop it now because WSN I need to start. So I will complete these two, WSN definition and WSN node, and next class we'll go for the M2M communication. What do you mean by WSN? It is defined as a network in which each sensor node connects wirelessly and has capability of computation for data compression, aggregation, and analysis plus communication and networking. The WSN node is autonomous. Anywhere you can keep it over there because it's not connected through wire. It is wireless. Anywhere you can keep it over there. Autonomous refers to independent computing power and capability to send requests and receive responses and data for forward and routing capabilities. So anywhere you can keep, anytime it can work over there. 24/7 it can work autonomously. No need of any inputs from the user. A wireless network consists of a spatially distributed autonomous device using sensors to comparatively monitor physical or environmental conditions such as temperature, sound, vibration, pressure, motion, or pollutants at different locations. I told you in Delhi, air pollutions can be very monitored. It cannot be controlled, it can be monitored. You have to check it out. You can check it out, what is the pollution, what is the carbon dioxide presence in the air, what are the other materials which are present, everything you can check it over there. Monitoring is different, controlling is different. Using sensors, we are able to monitor that. Similarly, wireless nodes. When it comes to wireless nodes, varieties of nodes are available in the market. Wireless node has limited computing power. It may change topology rapidly. The WSN network in the topology changing environment functions as an ad hoc network. A wireless network in that environment is generally, that is wireless node in the network, is generally self-configuring, self-organizing, self-healing, and self-discovering because everything will be taken care by itself. No need of manual intervention. No need to go and check it every day. Automatically, it's going to check its power, its consumption of power, its lifespan, everything. It's going to check on its own. So that is why it is autonomous, and also it is also called as self-configuring, self-organizing, self-healing, and self-discovering. So that's all for the day. If any discussions, anything you want to ask, you can ask now. So today's topic, what we have discussed, you can just refine it or revise it. We have looked into the softwares, we have looked into the different types of microcontrollers and what type of microcontrollers, what are the type of the softwares, middlewares, firmwares we have discussed. Then IoT platforms, different types of IoT platforms, especially Eclipse is playing very important role. Then we come across the what are the WSN, how exactly WSN is going to work. So this is the topics we have discussed. Kindly read. Only 2-3 pages I have covered over there. If you read those three pages, if you write once also, it's quite good. I want everyone to write them, so it will be good for you. Any questions from your end? Any questions? Any clarifications? Any doubts? Hope I can wind up the session. Say I want everyone to be interactive. At least 10% of you people interactive with me. No, then it will be, even I also feel that one, yes, whatever I am teaching, it's reaching the destination, reaching the end, other end. Otherwise, one-way communication is not good. Everyone see to that you will be reading the materials, will be listening to me. Shall I close the session? Good. I'm not getting any response. Hope I can close the session.
Yes, sir.
Thank you, Yogesh. I'm stopping the session.